Okay, so we were studying about operations in the last example. So one thing about operation is it will be it's the condition that operation will can only exist once on a single row. If you are operating on a particular row, let's say row number 3, then we can only operate it once in one step. For operating it again, we have to first write the final result of of the previous operation, and then further ahead we can operate now on row number 3. So my point is that wherever there are changes going to made, so we have to write the result first, and then only we can go ahead and do the further operation on that particular row or column. Clear, everyone?
Yes, sir.
Yes. So this is another example. We have to find out the value of k. Now there is a 3 by 3, 3 cross 3 determinant is given. There are three variables a, b, and c. And on the right hand side also a, b, and c. And there is the fourth variable k, which we have to find out. Now in the options, there are all constants. So we have to find out k. A, B, C is a variable in question only, and the A, B, C do not have any relation with the options. So we can let A, B, C, and there's no particular condition given other than that this can be any number. So let A be 0. Okay, but if we consider A, B, C, any one of them as 0, then the right hand side will become 0. And then the left hand side do not have any other k variable. So we cannot let any of the variables 0. Otherwise, what will happen is that we will not have k in the equation. Then how will we be able to find out the value of k? For that, we need not, it's a condition that A, B, C should not be 0. So that will be keeping k in the game. Okay. So now assuming A as 1, B as 1, and keep the game simple, as simple as you can make it. Please keep it simple so that your assumptions help you in the calculations. Now B A plus 1 becomes 2, 1, 1, 1, 1, 2, 1, 1, 1, 2. As simple as that. K into 1 into 1 into 1 into 1. So now its determinant will be equals to k. Finding out 2 into determinant 2, 1, 2 minus 1 into determinant 1, 1, 1, 2 plus, I should have later, plus this. We are taking considering the first row this time, plus 1 into the remaining 2 by 2 determinant. So first column, second column is equals to k. Is everyone able to understand that how have I written the expression of the determinant? How have I expanded the determinant? Here,
Yes, sir.
yeah, we have taken first row, and then we will take the minor of this element and will multiply, sorry, the cofactor of this element will multiply the element into its cofactor. So the element is 2, its cofactor is, we will exclude the respective row and the column. Whatever is left, we will find out its determinant. Into, we will multiply minus 1 raised to power I plus j. For this is first and first, this first row, first column. So I, that is 1 plus 1, that is 2 even. So the sign is going to be positive only, then negative, positive. And we have also discussed earlier that this particular position is for negative, positive, and then here negative, here positive, positive, sorry, here positive, then negative, here positive, and then negative here. So like that also we can remember it. But I just explained you that what is the root cause, why the sign is like this. Okay, now 2 into 4 minus 1, 3 minus 1 into 2 minus 1, that is 2 minus 1, that is 1, plus 1 into 1 minus 2, that is minus 1 is equals to k. 2 3 is a 6 minus 1 minus of 1 is equals to k. So k is 4. Any doubts, anyone? 6 minus 2 becomes 4.
No, sir.
So that easily you will be able to solve by assumption method, by value putting method. Basically, you have substituted unnecessary variables. Otherwise, we can also solve this question by solving the determinant. For solving the determinant, we'll apply some operations. So here, this operation is applied, and then -2 is taken common, and then will be. And even if you are going with this particular method, then whenever there is any determinant, so try to make any column, uh, try to make the elements of a row or column, let's say of a row, try to make the element 0 or 1. Okay, and 0. If you are able to make two zeros in a particular row, then simply consider that particular row, that respective row, to find out the determinant, and you will be easily able to find out. So your objective for applying operation is to make 0 in any row, or at least 1 0. If you are able to make two zeros in any particular row, so it's a great chance you will be able to solve the value of the determinant very easily. Is this point clear, everyone? Clear? See, here also what is happening, the given in the given determinant, they have made this particular this element as 0. How they have done so? They have subtracted the sum of the row number 2 and row number 3 from the row number 1. So b plus c minus of c minus b, that becomes 0, and the remaining are also going to become something. So now what is good? What good has happened is that we are able to make 0 in the first row, and then in the next step we are able to take -2 in common from the first row. Now this has become 0 1 1. Now it is very much convenient for us to find out the determinant. Why so? Because there will be less degree. Otherwise, we'll have to multiply b plus c into c plus a. Then we'll have to multiply, solve this much of variables in the calculation, and this will be very hasty to tedious job to find out the determinant using this long method. Right? So that's why operating on any determinant is necessary. The objective for any operations for finding out the determinant should be that in any particular row, I have to maximize the number of zeros or 1, so that I will be having ease in multiplying. Are you able to understand what I'm trying to say? Clear, everyone?
Yes, sir.
Yes. I request everyone to respond. Moving further. Now, here also, we have to find out the value of k. A, B, C are the variables on both of the sides. Now, there is, in the options also, A, B, C don't have any relation. So, we can assume A, B, C accordingly as per our convenience. So, can we assume A, B, C as 0? No, because then that will make this particular term as 0, and then after solving ahead, will not have any variable in the equation. ABC, we are already putting some values, so of what use our calculation will be if if there is no k in the equation. So that's why we cannot make ABC as zeros. So let's assume simple ABC as 1 only. Okay, so 2 into 1 into 1, 2 minus 1, 1, 1, 1, 2 minus 1, 1, 1, 1, 2 into 1, 1, 1, 2 minus 1 square, 1 is equals to a cube, 1, 1 cube is 1 only, plus k into 1, 1, 1 square. Okay, so this has become also 1. Now, this is also 1, this is also 1, this is also 1. Okay, instead of writing again, let's modify the determinant here itself. So now, do you remember one property that if the any two row or column of a determinant becomes identical, then its determinant is 0. So this has become 0 equals to 1 plus 1 plus 1, 3 plus k whole square. Taking square root on both sides, 0 is equals to 3 plus k. Now k becomes minus of 3. A should be the correct answer. This is how easy it is by value putting method. See, there is no restriction on us. Okay, we cannot assume ABC. For any value of ABC, this particular given equation should work. And that is what our basic assumption is. I have already told you why we are not taking ABC as 0, because then it will also work. Then the equation will also definitely satisfy. But taking ABC, any one of them as 0, will make our k vanish from the equation. And our objective is to find out k only. So we'll have to keep k in the equation. For that, we are ignoring the values of ABC as 0. Is that clear, everyone? Any doubts you may ask? Please reread it again, try to understand, contemplate over it, and ask if any doubt. Clear?
Yes, sir.
Okay, let's move then to the next question. And here also, what they have done is, oh, they have used another method. Okay, so they have divided it in factors of determinant and done it some other ways, which is very complex even to read and understand. This is called premeditated method. है ना? कि they know कि the question is going to solve this way only, so that they are able to find the solution very easily. But it's not that simple to even think for and expand the given determinant in this method. You need to do a lot of thinking. So value putting method is best, and it works. It most of the time in algebraic questions, in trigonometry, most of the times. Now it is very important applications of determinant in geometry topic. So in this topic, we are going to understand that how using determinant, will be able to find out the area of a triangle, or will be able to tell whether the 3 points are collinear or not. Collinear means if 3 points lie on a straight line, then these 3 points are collinear. If 3 points doesn't lie on a single straight line, then these points are non-collinear. Okay. So we'll be able to tell whether there are 3 points having these x1, x1, y1, x2, y2, x3, y3 coordinates are collinear or not. We'll be also able to find out the equation of a line passing through 2 points. Okay. So let's discuss them one by one. So we know that any triangle have 3 vertices. 1, 2, 3. Let's say they are given as x1, y1, x2, y2, x3, y3. So let me write here x1, y1, x2, y2, x3, y3. These are the vertices. These are the vertices of the triangle. Now we have to find out the area of triangle. So the area of a triangle will be given by half into determinant. Now into determinant, the third column will all be 1, and then the vertices will be the first and second, written in the first and second column. second vertex is in the second row, third vertex in the third row. As simple as that. Okay, so simply solve this, and there's an expanded form also written. If you want to remember it, simply remember it by half into x1 plus x2 plus x3, and they are getting multiplied by y2 minus y3. So 2 3, y3 minus 3 1, 3 1, y1 minus y2 1 2. Simply remember this number 23 31 12. I used to remember it in Hindi 23 31 बार 23 31 बार. You can do it, so you can do it by 23 31 12. 23 31 12. Okay, simply you have to understand this pattern. And if you're not that person who likes cramming, so simply go with the determinant form. No, simple. You have to learn, you have to write the vertices x1 y1 y x2 y2. Sorry, I've done a mistake here. X2 y2 x3 y3. These are the three vertices, and the third column will be having 1 1 1. Then you will be able to find out the area of any triangle. Now please tell me that if there are 3 points. Now 3 points are capable of making any triangle, but if they are lying on a straight line, then they will not be forming any triangle. So if we find out the area of triangle formed by these 3 points, should be 0, because the triangle is not formed, right? So simply to find out the condition, whether the given 3 points are collinear or not, we'll be finding out its area. If the area of the triangle formed by 3 points is 0, means they are not forming any triangle, means they are collinear. Collinear. Okay, so here also the formula of area of triangle is written, and then it's equals to 0. Half is missing because half is not having any significance, because it's getting multiplied to something variable is equals to 0. So half cannot become 0, only the variable is going to become 0. That's why half is ignored here. You can write half here for your convenience of understanding. Coming to the third point, you can also find out the equation of a straight line passing through 2 points. How you will be able to do so? Let's say there's a A point connecting to a B point. The vertex of the A point is x1, y1. The vertex of the B point is x2, y2. Now you have to find out the equation of a straight line. Then it will be simply written as, sorry, yes. Now write x and y as the general variables, and the third column will be completely 1. And simply the vertex, the first vertex in the second column, second vertex, the third column. This should be equals to 0. Now solve this. You'll have x and y as general variables, and these are, as you know, there will be points, so these are going to be constants. So this is how you are able to find out the equation of a line. Is that clear, everyone? Are these 3 points clear? Please reread the slide. Observe it. Absorb the material. Done? Everything clear?
Yes, sir.
Okay, so a question now. In this question, we have to find out the equation of a line passing through the given points. So for any equation, general variables, the third column is going to become 0. Now the vertices 1, 2, 1 minus 2 should be equals to 0. Okay. Solving this, taking the third column to solve. Okay. 1 into determinant of 1, 1, 2 minus 2, minus of 1, okay, into determinant of this time, this time. So xy 1 minus 2 plus 1 into, and you don't have to write like this. I'm just writing to make you better understand. Xy 1 and 2 should be 0. So minus 2 minus 2 and minus 2, this minus 2x minus 1 into minus of 2x minus of y into plus 2x minus of y is equals to 0. So now minus 4 minus minus plus minus minus plus 2x minus y should be 0. Plus y minus y cancels each other. 4x on the left hand side, minus of 4. Let's bring the minus 4 onto the right hand side. So simple, x is equals to 1. 4 cancels 4, x is equals to 1. D should be the correct answer. Yes, it is the case. Any doubts, anyone?
No, sir.
Yeah. Why exactly I have taken third column? Why not first row? Using first row will be also able to find out, but I thought that was much easier than solving this through the first row. That's why. And it's our freedom of choice that we can pick any column or any row and then multiply respective element with their respective cofactor, and then we have to sum them. Okay, so now this particular thing is going to be really important. In earlier classes, when we have to solve two linear equations with two variables, x and y, then what we used to do, let's say there's a equation in x1 in x and y, a1 x1 to b1 x2 is equals to c1. There's another equation in x and y. b2y in x and y. Na? So now these are the two linear equations where a1, b1, and c1 are real numbers. They're constants. Okay. So earlier we studied this in smaller classes, that when there will be a unique solution for x and y, when a1 by a2 will not be equal to b1 by b2. And when there will be infinite solutions for x and y, when a1 by a2 is equals to b1 by b2 is equals to c1 by c2. And whenever there is any solution existing, we used to call the system of equation as consistent. Because there is a solution that is existing. Do you remember? Anyone remember about this?
Yes, sir.
Yeah. And there will be no solution.
Yeah, where
When,
everything, like the first one will be not equal.
when the third one will not be equal.
Oh,
C1 by C2 ratio will not be equal.
okay.
So this is what we earlier used to study using the ratio method. We were able to guess whether we'll be able to find out the unique solution or there will be infinite solution. Infinite solution means it doesn't matter whatever you put x and y, the equation are going to get satisfied for sure. Now we are going to study it using the determinant method. So here also we'll have a1 x. You can already see the equations written here. Okay, so now we are going to write determinant as the coefficient of x and y, a1, b1. In the second equation, a2 and b2. Now this is a determinant of 2 by 2 order. If we replace c1, c2, let me write the equations here. You'll be able to better visualize if they will be written in this format. So if we replace the first column with c1 and c2, then it becomes d1. Okay. Now the second column is same intact. We have exchanged the first column with c1 and c2. This will be known as d1. d2 will be called as the first column will be intact. Second column will be exchanged with c1 and c2. So this is what d1 and d2 is. Now, as per this Cramer's rule, the value of x will be d1 over d. The value of y will be d2 over d. Okay. So this is what Cramer's method says. Now we will understand the condition for consistency when the solution is going to become no solution, when there will be infinite solution. We are going to understand it. Okay. Okay. Before that, first understand key what is d1 and d2. Yes, and what is x and y. Is this clear, everyone? Yes. Is this clear, everyone?
Yes, sir.
Yeah. So now let's study about the condition of unique solution. There will be unique solution for x and y when d is not equals to 0 and d is a non-singular matrix. And there will be no solution. Okay, let me write no solution later on. There will be no solution for x and y when d is not 0. When d is 0, sorry. But one of, I'm not writing all of them, but one of d1 or d2 is non-zero. Then there will be no solution. Okay. When d1 is 0 for sure, but one of d1 or d2 is non-zero. Let me rewrite it, this condition little well. And there is one more contingency when d is equals to 0. When d1 and d2 both are zeros. Here, one of d1 or d2 were 0. But when d1 and d2 both are 0, then what will happen? When d1 is equals to 0 and d2 equals to 0, then there will be infinite solutions. So what is happening here? X will be 0 by 0, y will be 0 by 0. That's why infinite solution. No solution because one of d1 or d2 has become non-zero. Then that's a contingency of no solution. Now, as we know, whenever there is any solution existing, in case of unique solution, infinite solution, there is consistency in the equation, the system. And whenever there is any no solution, contingency, then the system is inconsistent. Is that clear, everyone? Is that clear what
Yes,
is
sir.
unique infinite solution? Great. So this is what we discussed about system of linear equations in two variables. And there are two linear equations as well. Two linear equations with two variables. Now let's study about three linear equations. Okay, sorry for interruption. Three linear equations in three variables. We know what are the three variables. Linear equations in three variables. So first linear equation can be a1x plus b1y plus c1z equals to 0. X, y, z are the variables. A1, b1, c1 are the other constants. It may not be equals to 0. It can be equal to anything. Third equation is now A1, B1, C1, A2, B2, C2, and all these other variables than X, Y, and Z are constants belonging to real number. Okay, so here in this case, the Cramer rule says then the D is equals to A1, A2, and A3, B1, B2, and B3, C1, C2, and C3. This is basically D. For making D1, we will use D1, D2, D3, we'll make its column and replace with the first column. So that's why the D1 becomes D1, D2, D3, and the other columns remains intact. Similarly, for the D2, second column changes and others remain same. D1, D2, D3 here, and this remains the same. For D3 this time, because there's one more column to replace. Third column becomes D1, D2, D3, and other columns remain the same as of D. So A1, A2, A3, B1, B2, B3. Now, is that clear ki how we are making D1, D2, D3? What are these? So this is D and these are D1, D2, D3. Same rule apply here also. Same rule apply. If D is not equals to 0, then there exists unique solution for x and y and z. If D is equals to 0 and one of D1, okay, let me write this condition later on. And D is equals to 0 and D2, D1, D2 and D3 all are 0. Then there will be infinite solutions. If one of D1 or D2 or D3 has become 0, then there will be no solution. Okay. So in the upper two cases, when there is some solutions, the system will be considered as consistent, otherwise inconsistent system. Now this when the system is consistent, when this is inconsistent, when there are unique solution, when there is infinite or no solution, these conditions are really important and questions are asked on basis of this only. And the most important thing that when what is x here? X is basically d1 by d. What is y? Basically d2 by d. And z is d3 by d. Same as of two linear equations in two variables system there was. So it is the same system here also. So this is this method is known as the Cramer's method. Please read the slide and try to understand what we have just discussed. Clear, everyone? Any doubts? If any, please ask.
No doubt, sir.
No doubts. Okay, so this is one method using determinants. There's another method using matrices. We are also able to find out the value of x, y, and z. Let's discuss that. So now this time, instead of making determinants, we will be multiplying some matrices. So let me write the A matrix as of 3 by 3 order. The matrix of variables x, y, z. The order of this matrix is 3 by 1, 3 rows and 1 columns, 3 rows and 3 columns, and one more matrix of the results d1 and d2 and d3. Now basically this matrix is also following the order 3 by 1. We multiply a and x. What will be the result? Can anyone tell me? What is the multiplication result of a and x? Just tell me the order. If you multiply matrix A with matrix X, then what will be the order of the resultant matrix? Please do it fast. It's simple, yaar. Order तो निकालना है. Just have to find it the order. 3 and 3 are the same, so they are okay to get multiplied. What is remaining? 3 and 1. So its order will be 3 cross 1. As simple as that. Okay. Now, if we smartly multiply the first row with the first column, so it becomes a1x plus b1y plus c1z. Now, there's no other column to get multiplied with. Okay. Now, moving on to the next row. a2x plus b2y plus c2z. Okay. So, what I'm trying to say that when we will multiply a and x, that will be becoming the left hand side of these three equations. So, we may write this is becoming equal to b. And now this equation is very important. Now we will pre-multiply by A inverse. Okay. So the pre-multiplication of A inverse will make it A inverse into A into X into A inverse into B. A inverse, A inverse, A inverse into A becomes inverse matrix. Sorry, identity matrix. Identity matrix when gets multiplied to X, that becomes that becomes X only. and x will be equals to A inverse into B. So basically to find out the value of x, that is x, y, and z, you will have to pre-multiply the inverse of A matrix into B. Now we all know what is A inverse, adjoint of matrix A divided by determinant of matrix A into matrix B. So this is what typically it will look like, but in questions and books, and even in memory, for the memory also, this particular form is better to remember. So this is what, this is how we can solve using finding out some matrices. Okay, if we are going with this method, first please tell me if this method is clear or not, or should I explain it more? Should I repeat? Yes, anyone? Or is this clear? Clear, everyone?
Clear, sir.
Okay. Now, if you think about the multiplication of A inverse order will be 3 by 3 and B's order is 3 by 1. So if you multiply both of these, 3 are the same. So what is remaining? 3 cross 1. X is also 3 cross 1. So basically, after equating those two matrices, you will be able to find out the value of X matrix. Okay. But what about the conditions in this particular method? When the solution will be infinite, when there will be infinite solution, when there will be no solution, when there is unique solution. So for that, simple, if A's determinant is non-zero, then there will be unique solution. When A's determinant is 0 and when the multiplication of adjoint of A into multiplication of B, that has become 0, then there will be infinite solutions. If the multiplication of adjoint of A and B matrix is non-zero, then there will be no solutions. These two first conditions are going to make the system as consistent. The third condition will make the system as inconsistent. Okay, great. So are these conditions clear, everyone? What is A? Basically, A, this is the matrix, and we know A, while finding A inverse, we'll have to deal with adjoint of A. That's why adjoint of A is relevant here, right? So I hope everything is clear. Is that right?
Yes, sir.
Okay. Now there's one more. Okay, we have already discussed about all of these conditions. Now, yes, homogeneous and non-homogeneous system. We were earlier talking about D1, D2, and D3 matrix, D3 determinants. If these all three determinants becomes equal and equals to 0, then our system will be known as homogeneous system. And this particular thing can happen. First, let me, I want you to see what is D1 and D1, D2, and D3 once again. So observe here. Observe here. What is D1 and D2 and D3? So when we know when any particular column or matrix or row of the determinant becomes 0, then only then we can definitely say that the determinant of the matrix is 0. Okay, so if we have a look on them, so we are able to understand that D1 or D2 or D3 may become 0 when the common column between all of them becomes 0. Means when D1, D2, D3 becomes 0, means that that we were referring to, that the right hand side of all three linear equations becomes 0. Means D1, D2, and D3 become 0. So this is one possibility when D1 and D2, D3 can become 0. Or maybe it is happening that one column of D is entirely 0, 0, 0. So these two possibilities are there. So I don't want to confuse you. Basically, the parent condition is this only. When D2, D3, D2, D3, and D3 all are becoming 0, then the system will be known as homogeneous system. Okay. So I believe that this has given you enough understanding about homogeneous system. Now, what is important in this is that first let me give you an example. So if three equations are equating to 0 like this, then this is a homogeneous system. Or if they are equating to some constant but are missing as but are having only two variables, then this is also a homogeneous system. Okay, so this is how you can identify them. Now let's talk about their solutions. There can be only two solutions for x, y, and z here. One solution is that when x and y and z all are equals to 0, and this particular solution is known as the trivial solution. And this is not exactly a solution. This is neglect. This is neglection. This is neglection that their solution can be finded out. So this makes the system inconsistent. And this will happen only when the determinant is non-zero. But when the determinant is 0, then x, y, and z will possess infinite values. Infinite solutions will be there. If there are infinite solutions, the system will be considered as consistent. And these conditions that I have written on the slide are very important because they are constantly asked in the exam. Constantly questions are made from these conditions. I hope everything is clear. If please read the slide again. If any doubts, ask. Please do write. Please do read. I'll share the PDF of the class in the WhatsApp group, but please read so that you can think about the method. If you think, then only questions are going to pop up in your head. Okay, done reading?
Yes, sir.
Yes, sir.
Any doubts?
No.
No, sir.
Any doubts? I'm asking again. No
No, sir.
doubts? Okay. So let's solve an example. Now, these are some equations given. Three equations are there. X, Y, and Z, three variables are there. Okay, let's first write them in some, let's write all the variables on a single hand side. So X minus CY minus BZ is equals to 0. Minus of CX minus plus of y minus of az. Now I have smartly written x term first, y term second, z term third. You have to maintain the order. Z minus of vx minus of ay is equals to 0. Now you can exactly see that this is a homogeneous system because d1, d2, d3 are 0. Now it is given that x, y, and z are non-zero. If they are non-zero, then like there will be x, y, z will be having infinite values, and that can only happen when the determinant is 0. Okay, when the determinant is 0. Okay, so let's write the x coefficients 1 minus c minus of b minus of c 1 minus of a minus of b minus of a and z equals to 0. Now we'll have to find out solve this particular given determinant, and then we'll have to cross check with the given options. Now I'm lazy. Okay, I'm lazy. I don't have that much time, so I'll just assume some values of a, b, and c. Oh, there's no z here. Sorry, we only have to consider the coefficient of z is which is 1. Okay, so I'm lazy. I'll just substitute some value of a, b, and c, and whatever the given whatever the answer will be. Wait a moment. But we only have three variables on this side. So if we substitute them, then how will we be able to find out? How will we be able to cross check with these? Okay, so instead of substitution, I will substitute only two variables here. Okay, let me substitute b and c. Then after substituting b and c, I'll left with one variable in the equation. I will find out a then. Okay, after finding out a also, b and c I have already assumed them. Then I'll cross check with these options. So that's a great method to go with. So let's assume some b and c as some convenient values. So if they are having minus with them, so let me consider b and c as -1 and -1. Okay. So now the determinant has become 1, 1, 1, and this is minus of a, 1, and 1, of course. -1 into minus, plus 1 to minus of a. This is 0. Now let's solve this determinant on the next page. Let's do it fast. 1 into 1 minus a into minus a, that is plus a square, to minus of a into minus of a into -1. Okay, minus a into -1. Okay, plus 1 minus of a to minus of a, that should be 0. So 1 minus a square minus a plus, sorry, plus minus minus makes it plus a plus 1 minus a minus 1, there's no 0. So this cancels, these four terms cancel each other. 1 minus a square is equals to 0, so 1 is equals to a square. Bring the a square onto the right hand side, so a becomes plus minus of 1. What we had b as minus of 1, c also had minus of 1. Now let's cross check with the options. So we have abc's value. Now we will check with the first option. using the values which we have of ABC, if the first option is verifying means left hand side is becoming to the right equal to the right hand side, then we say that the option is verifying. And we will check all of the options. If two options will be getting verified, then we'll have to assume some other value of B and C and then repeat the process. But it has lesser chances. The risk is low here. So that's why we are going with this. Okay. So A is plus minus of 1 and B and C are minus of 1 basically. So the A option, A square plus minus 1 square is 1 only. B square is 1 only, C square is 1 only, plus 2ABC. Now we'll consider A as plus 1 first. Okay, so minus B into minus C, that has become plus 1 also. And A was already plus. A was already plus 1. So this has become 3 plus 2, 5 is equals to 1, which is not true. So with A is equals to plus 1, A option is not verifying. Now let's check for A is equals to minus 1. A square and B square, they are all plus 1. Plus 2 into A is minus of 1. B and C minus 1 becomes plus 1. Should be 1. Okay. Now 1 becomes 3 minus 2 is equals to 1. Left hand side becomes 1, right hand side was already 1. So A option is getting verified with A is equals to minus 1. Now there are higher chances of A becoming minus 1. Now let's check with option number B. 2 into A square is 1, B square is 1, plus 3 into A, which is minus of 1, which we are considering first now, into B. B is minus of 1 is equals to 1. 2 plus 1 plus 3 should become 1, which is not going to happen. 6 is not 1. So B option is eliminated. Even if we take my plus of 1 here, then this will become 2 plus 1, 3 minus 3, which is 0, and 0 is not equals to B. That's why B option is eliminated. Similarly, we'll check for the C. 1 plus 2B square, 2 plus ABC, so that's minus 1 or plus 1. So we can consider the both values simultaneously by writing 3 plus minus 1 is equals to 1. So whether 4 or 2 is not equals to 1, so C is also not the go-to option. Higher chances of A getting correct, and yes, A is the correct option. Okay, most of the times answer will be out of the question, out of the option only. Most of the time, all of the time, the answer will be from options only. Okay, so I'm running out of time. Okay, thank you everyone. Do you have any doubts? Anyone? Any doubts?
No, sir.
No, sir.
Thank you, Jai Hind.
Thank